So we had the SID DisplayWeek, and hi, so who are you?
Hi, I'm Alain Lacourse, application engineer at Boréas Technologies.
Hello.
Hi, I'm Nicolas Duchesne-Laforêt, marketing manager at Boréas Technologies.
So what do you do here at Boréas?
So Boréas, we're a fabless semiconductor company. We build, we create drivers for piezoelectric actuators.
Is this something in here?
Yeah, it's something in here. It's the small part here. So there are two of our chips here with the required component. The piezoelectric actuator would be connected here, and this board is our development board that connects to the PC. And
so what is this? What is happening here? What is this part?
So this part is an inductor, and there's a R chip, and the other are basic components required for making the part operate.
And so you are able to do haptic, piezo, haptic feedback instead of the normal haptics are done by a different way. How is this different?
There are different technologies to do haptics. There's the ERM, which is the first rotation motors that you found into cell phones. More advanced cell phones today are using LRAs, and piezoelectric actuators are the next wave of haptic devices. And we have designed a driver that is low power, small footprint, and that is designed basically from the ground up to make these devices operate. So our chip can do can drive drive the actuator and also sense how much pressure the user is putting on the
So
device.
here you have a demo phone. So the phone could have haptics on the side, for example?
For example, we replace the mechanical button by a piezoelectric that is inside the screen, not the screen, sorry, the frame. And when we push on the frame, the user feels a simulation of a button.
So it feels like a button, but there's no button, so it makes it easier to build a phone?
It makes it easier to have it sealed, to have it more rugged, and also to create haptics at any location in the device. So we could have a device under the screen, for example, and have the user press the screen or feel some typing when he's actually using the keyboard, for example.
A usual haptic system has only one for the whole phone, right?
One for the whole phone.
Is that what you do also?
You
can have several.
That's something that could be done. There are different possibilities with that, and it's really the good point with the piezo is that it's in direct contact with the surface that's in the direct contact with the user. So the effect is direct. It can feel both the pressure and give the feedback.
But you can't do it right now where it's one that does everything, or you have to localize several, or right now you put it just behind the...
Right now we've put it just on the frame. So there's no device inside underneath the screen. It's only inside the frame.
Nice. And what do we see here? What is this?
This is the... Yep. Yeah. Those are the different package that we have for the chip. So the first row you can see actually I cannot show you that part.
You cannot show that part?
No.
Okay.
You can see it with your eyes, but
yeah,
you're not supposed to.
Okay, cool. Okay.
Yeah.
So how can people use the development kit?
So the development kit is the first step for our customers to get experience with piezoelectric actuators. So they can connect the actuators on the end. They can plug it into the computer, and it's recognized by the computer as a USB speaker. So out of the box, you can have access to the press and release simulation demonstration. You can also play waveforms directly through from the computer to the board. They will be played on the actuators. And then once the customer is ready to go to the next level and build his prototype, he can reprogram the microcontroller from the source code that we provide. And one step further to build his prototype, he can break the board in 3 pieces, and those 2 pieces can be directly connected to his system